start doing bicycles and those kind of things. As soon as we start speaking, we want a bicycle that you do not need a handle. Your brain starts thinking about it and you create an image about it and you're almost married to that idea. That's one of the worst things you can do. Okay. You always got to be creative and think about it, but we still need to go through all the process. Okay. So the first part is going to be, of course, we have a problem. So it's very important not to assume that there's a problem. Okay. Like there's if you, I think the most famous story about this one is the NASA pen. Has anybody heard about the NASA pen that they designed for able to try ride in space? I see Patricio saying yes. You want to tell us about that story? Or do you want me to tell it? Somebody wants to tell me that story?
Uh, okay, I'm gonna try. Like my English, it's not like
No worries.
okay. But I know that when the astronauts went to space, their pens didn't write because the gravity is what the ink make the ink go to the ball. But
Correct.
there's no gravity, so they have to think in something that allows them to write in space. And they
Correct.
came with a pen that has like nitrogen, I think. I don't remember which gas were there, but they let them write in every angle, like in well, in with no gravity. So that's pretty much.
Yeah, that's true. So NASA, when they were sending the Apollo missions, no, they wanted to send people like you and said, okay, so while you're at space, please write down everything you see. No, if I throw this pen and it starts spinning this way, just write it down. If you take an ant and it dies, write it down. Write everything down. And of course, like good students, they went to space, they came back and they said, hey, what's going on? Where are all your notes? And they said, we couldn't write. Our pens, everybody has a beak. No? No? So they gravity pushes the ink and you can write. That's why with this pen, when you start, if you want to become a criminal and start painting in the bathroom wall, okay, and you start writing makes no era penal, okay, in the bathroom, and then you realize that it stops painting, right? So you got to do this. You got to bring your shoe out and paint on your shoe and starts painting, and then you start doing the penal, okay. So that issue, because they couldn't do this or they couldn't do that because there was no gravity, it would not paint. So we had a problem, right? NASA had a huge problem there. Okay. They wanted to realize, they wanted to be able to make sure they were putting people into space for them to be able to write. Okay. So evidence, it's what makes you be sure that you have a problem or start making sure that you got a problem. Okay. So this was pretty easy. Astronauts had gone to space, came back, no painting, we cannot paint with our pen, right? So we have already validated, okay? Some of the most normal ways to do it is doing interviews, searching for data. I'm going to try and show you how to do that. Doing testings, okay? If you're going to do like a new product somewhere, there is everything that has complaints, like Amazon is one of the best places if you wanted to validate a product. So if you have this new idea, like, okay, I want to do this new water tank that does not leak because I put it in my backpack and then all my books and notes get soaked. Okay, if you want to know which designs are working and which ones are not, Amazon is a great spot to look for. Everybody complains about a faulty product. Okay, so search on it. It's really a good idea. Okay, of course, patent is the professional way to do it. Okay, and then you do the scope. Okay, how are you gonna tackle it? Okay, which are the ideas of how to tackle it? Okay, the scope, it's one of the most important things, and we're gonna take almost a full day to do the scope, because this part that highlighted is one of, it's vital for your correct development of the product. What will it not be? Have you ever had one of these ideas, or this is the typical discussion between a boyfriend and a girlfriend with a boyfriend, or mom with one of any of you. If your mom tells you, can you go upstairs and clear that room? You'll go upstairs and clear that room as ever you believe she wanted it to be cleared up. Okay? Then she comes upstairs and she says, you didn't arrange the pillows. No? The curtains are still dirty. No? Did you mop the floor? Has that happened to any of you? I'm guessing all of you. It happens all the time because it was never established what you want and what you do not want. Okay? If you do a correct scope, you would have asked, okay, you want me to go upstairs? I'm going to pick up all the toys from my brother. I'm going to clear up all the pillows on the furniture. I'm going to swap the furniture and I'm going to put all the PlayStation games back into the cover. Is that okay? And she comes back and says, no, please clean the windows too. Now you got a correct scope. Now you know what she's expecting you to deliver. Okay? So this part is going to be very important because in an initial meeting with somebody that's going to pay you to develop a new product, or when you're going to talk to the people about what you want them to develop, help you develop to be able to create a product, everybody's very friendly. My experience is everybody's very excited. So yeah, we're gonna do this that has this thing, and we're gonna place this other. Oh yeah, and then everybody's excited. Everybody gets out of that meeting saying, "We're gonna become a millionaire. We're so good at this. This is the best idea ever." And then one guy starts developing something, and I'm gonna be very stupid at this part, but it's like you start real in your brain because nobody's talked about it. You're a Manchester United fan, so you start thinking about it in red. But the owner is a Manchester City fan, so it starts becoming blue in their head. Okay, and there's going to be a moment you cannot do a red or a blue product. It has to be red or blue. Okay, so that's very important. So in the scope, it's very important what you need to do. So here in the scope, NASA had to say, in this case, we want a pen that can write in zero gravity. Okay, that was their scope. That was as big as the scope was. Okay, and then they started doing prototypes and everything. But here, I'm just going to make a pause between the scope and the evidence. Here's where you make sure that it's worth it doing. Okay, so the full story about the pen of NASA is this was in the 60s. Remember when you were not even planned. Maybe you're not even your parents were alive, so I was not alive either. Okay, so they were sending astronauts, and there was a big war against the Soviets because they were Soviets at the moment. Okay, and they were trying to put somebody in space first, going to the moon first, doing all of those things, right? We all know the story. They did Laika first, so they put the first living animal in space. The Russians, the Soviets did, and then they put the first astronaut over there. Okay, and then the Apollo's missions came through really, really quick. Okay, so Apollo's missions come in. They come up with this idea of the product. In the 60s, the development of it was not this pen, but the pen that would allow them to write in space cost $1 million in the 60s. Okay, you can imagine how much that cost. Okay, for you to have an idea, a car in those years cost $2,000. A car. They spent $1 million doing a pen. Okay. Then they had this huge seminar. Okay. They wanted to, the US being the US, wanted to show up their beautiful pen they could write facing up, facing right, left, whatever they wanted. You know what the Russians said? Somebody knows the rest of the story? Because the Russians had already solved this issue. Does anybody know how they solved it before and way cheaper? No one? Ian, tell me.
I think they just used a pencil.
That's correct. They realized that a pencil could write without gravity. and they took a pencil to space. Imagine the joke. You got probably some of the most brilliant minds in NASA spending $1 million, probably a year, in a product doing every single of these stages, every single one. And when they realized, they didn't really do the evidence part. They didn't go through all the ideas. What happened with NASA? Exactly what I was telling you before. They spoke about, we need to make a pen that can write in space. The first thing they thought is, it does not write because gravity. Okay, so who's the bad guy here? Gravity. What do I have to do? I'm going to attack gravity. I'm going to make sure that gravity does not affect my pen. That was not the issue. What was the problem? Was it gravity? No. What was it? I wanted to write in space. People in NASA got this first point confused. They didn't want to destroy or attack gravity. They didn't want to get rid of gravity. They wanted to write. How much do you think a pencil cost in the 60s if a car costed $2,000? 5 cents? Imagine this. $1 million because they didn't go through all this process. They jumped between processes. They went directly into the scope to say, we're going to make a pen that can write without gravity. Okay? So be careful with these first stages. If you do write these first stages, these 4 first stages, I can tell you, you're going to have a very successful product. Or at least you're going to be able to have a bigger chances for it to be a successful product. Okay? Prototypes and testing. So we're going to see those. I know for your generation, this part is way easier. Okay, so you can have 3D printers, metal 3D printers, routers, everything very cheap and very available. I'm guessing most of you probably already have a 3D printer at home, at least one of those plastic ones that are pretty good, pretty cheap. No? But we're going to see when it is worth it to do testing, when it's not really worth it doing testing, and how we do it. Okay. Then we're going to know how to validate that testing. And finally, what are the documentation that we need? I know as an engineer, I can tell you, this part is horrible. Having to do all the data, having to write all the documentation to get a patent is one of the most painful things you'll ever do. Forget about the thesis. Well, I know you guys don't do thesis anymore, but nothing to do with this. Well, actually, if you do a master's or a PhD at UP, you still got to do, I think, a thesis. So that one is easy. Against doing all the documentation. Okay, and this one is the one that's going to make you be able to put it on your name or not. Okay. If you got any questions, just let me know. Okay, I'll speak a lot because there's a lot of material. Okay. So this is how I'm planning to grade your class. Okay, I'm very open to you. If you want to change anything, I'm okay with it. I'm not here to fail anyone. Of course, I do expect people to work. Okay, so it's going to be 3 weeks. The first of the weeks, we're going to be seeing some of what's a successful design, how to get your evidence, how to create your scope, and there's going to be some teamwork. Okay, I'll get to it in a second. So I would think we can do a small maybe Google exam, something like that. You call it opción múltiple. So we can just do a small, because I know I need to do some tests. So we can do that, and we're going to work in a team, in teams. I think we're 13 or 14, so that's going to it's a prime number, so it's going to make it difficult. But we can do maybe 4 or 5 teams, and you're going to work during all the 3 weeks in your own product. Okay. So you're going to hand me that first stage. That's going to count 10%. If we can change this numbers. Second week, it's going to be the same thing, a small exam with a second delivery. And on the third week, I'll be in Mexico. we can do a final examination that you're gonna actually present your product. Okay, you're gonna tell me if it's doable, not doable. How are you gonna do it? What are the restraints and everything? And then you're gonna do that's gonna be 40%, and the final exam that will cover all of it, maybe 20%. Are you guys okay with this? You want to change it? Say now. I think Sebastian has to has to show that push again and turn on his microphone, his camera again, and let us know what he thinks about these scores. No? Everybody's okay? You're very compliant. Jaime says he's okay. Rafa says he's okay. Guys, you're too easy. One of the most important things in product development is know to put your stand. Okay? If I suddenly decide to change this and you're going to say, well, yes, he's a professor, it's okay, blah, blah, blah. No. You got to fight. No. I don't think we got enough time to have a first exam. I don't like 40%. We're playing all our, because if you fail the last one, you might not make the course. Okay, you want to fight this? Shall we just keep on going? Keep on going at it. Okay.
Probably we can change the 40% of the final.
You want to change the 40%, Rafa?
Probably I won't make higher the percentage of the weekly assignments.
Okay, you want to do 15, 15, and then we do it down to 30?
Yeah.
Everybody,
Yes.
thumbs up to whoever is happy with Rafa's. I see Maria Victoria is good. And is asking for you can talk. I'm not really into those microphone things, so go ahead. Oh no, he disconnected his microphone. Okay, so it's 15, 15, and 30. Okay, so you guys played my trick. I told you fight for it, and you never asked what was the weekly assignment. Did you realize this? She just gave more weight to the weekly assignment, and you don't know what it is. Sounds normal for you? Is this the way you negotiate in life? Okay. Okay, so let's think about it, okay? So this is what you're going to must be able to deliver, okay? At the end, we're going to do teams, and you're going to be able to justify your choices in every single of these stages, okay? With a document, and you're going to do a small presentation and blah, 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 to defend this one. To be fair, you're very lucky. I'm going to be very easygoing in this course. I wanted to push you to do this because the weekly assignments, the only thing you got to do is put together all the daily assignments and hand them to me. Okay? So it was good that you negotiated this part, but guys, always ask. You don't know what they're asking. Okay? In a big project that I've worked with, people can come over and say, yeah, I want everything to weigh maximum 3 kilos. Okay? And your engine is 500. Before you even knew that they were going to take off 2 kilos, no, you already said yes. Because yeah, we can do that. Why not? Okay? So be careful with that part, okay? Okay, so let's do, so you're going to be working in 2 projects, okay? One of them, we're going to be working in it every class, and at the end of every week, I'll be handing you some sheets that you got to work with in a team, and at the end of them, you're going to fix everything you need to present on that one, and you're going to send it to me, okay? So that's your weekly assignment. It's going to be very easy for you to do. The topic about that weekly assignment is, at the other end, that you can change the cartridge, okay? In Spanish, it's going to be un desodorante de cartuchos intercambiables, okay? So you're not going to throw it away. You're going to have maybe like the vape, okay? So you're gonna have your nice fancy little box, and then you're just gonna be changing the product that you put on your body. Okay, so we're gonna do all the stages through that one. Okay, and at the end of this class, we're gonna choose teams. You guys are gonna select I want to work with this guy and this guy. If not, I'll just do it because I don't know any of you. Okay, and you're gonna do a single project by yourselves of class and deliver it at the end of the class. Okay, that's going to be your final product, your final delivery, the 30%. Okay, is that clear for everyone? Yeah, good.
Sorry, could you repeat what was the weekly assignment, please?
Yeah, so the last assignment at the end of this class, we're gonna make teams. It's gonna be probably 3 people, 2 people in each team because well, it's 14 of you, so it's a difficult number. But what you're gonna choose one of the I got already prepared like 8 ideas that you're gonna be working on. You choose one as a team, and you're gonna do all the stages that we did over classes, but you're gonna do it as a team of class, and you're gonna present at the end of on the last class that we got. It probably it's Friday, I think it's 10, something like that, July 10, something like that. So you're gonna be presenting with me over there, and you're gonna go through every single stage, and you're gonna show me, no, what was the problem, what's your evidence that you were able to find, how did you wrote your scope, what were the ideas, which one you selected, what was the final design, what was your prototype, what did you consider for testing, and what was all your documentation. It's a little bit tricky, like the prototype and the designs and all of those things, because I know you're all from different engineering programs. I don't know if you guys use SolidWorks or not. I don't know if you guys have done ANSYS or some of those other projects software before, but we're just going to try and make it manageable for all of you. Of course, I would recommend if you're like in a mechanical or a design program and you already know SolidWorks. SolidWorks is the most fantastic tool that you'll find anywhere. Okay, so you can do all of it in that tool. So probably just start working on it. Okay, so well, somewhere back here you'll see the topics. You guys will choose one, and then it will just work randomly. Well, you'll be working on that during the class. We're going to go through all the stages of this one. Okay, so you're also going to be working on the same teams, and then we're just going to every day at the end of the class, I'm going to give you a worksheet. You can work on that sheet to be able to know what is expected, and you're going to have 4 by the end of the week. You hand those 4 as a team, and that's your 15% for the week. We do a small option multiple exam Thursday, and probably Thursday before the end of the 3rd week, and that's going to be 10, 10, 10, and 20. Okay, and that's how you're going to be graduating from this class. Okay, any questions about it? Because I know this part is very important for you guys. No, all good. Okay, good.
No, yes, Diego, sorry. How many people should we consider in the team?
So what I saw, I think Miss Quack has 12 students, and there's one student from Ciudad Lupe. So that's 13. So probably I wouldn't like to do more than 5 teams. So maybe we can do 4 teams, maybe. Yeah, probably 4 teams. Let's do a couple of teams of 3 people and 1 team with 4 people. Of course, the team that has 4 people will have to include probably I think it's Carlos. Am I right? From Ciudad Lupe. Is anybody from Ciudad Lupe there?
I'm from Ciudad Lupe.
Rodrigo. So, Rodrigo, you're the only one from Ciudad Lupe?
Yes, I think so.
Okay, so Rodrigo, you'll have to join somebody in Miss Quack, and you'll be the 4th member of that team. Okay.
Perfect.
So we'll do teams at the end of class, so you guys can kind of think about it. But yeah, okay, all clear. Rodrigo, are you going to be able to go to Miscuac on the last week that I'm in Mexico?
Yes, I will be able to go to Misquack.
Great. Fantastic. So let's get started.
Pardon me, is that like assignment for the first week or for the whole course?
So the one that we are going to sign at the end is for the full course. Okay. So you're going to be doing two at the same time. The one that we're going to be doing at the class, and we're going to go through all the stages at class. Okay. So for you to see how it's done. And then you're going to have to work on your own project. Okay. So it's going to be like your homework, let's say it that way. Or you can just get together for an hour or so, or I'm going to try and give you some time within the class time to be able to work on your own project, to be able to finish it, because I do know that it's a World Cup and everybody wants to see Argentina today. Okay. By the way, constraints, evidence, and scope. I messed it up with this class because I'm a big football fan. Okay. And I wanted to make sure that you and I could watch the World Cup. So I decided to do this class at this hour so we would be able to finish before the first class. But I didn't realize that Mexico City, or Mexico, no longer has winter and summer time. So you don't change time. And we do in Spain. So now we're 8 hours ahead. And when I planned with Isabel the course, we were 7 hours ahead. So that's an assumption I took, that you guys would change time. And I never validated. So now we're going to suffer, all of us, for 2 games, Portugal and Argentina. So I'm sorry for that. Okay. So let's get started, guys. Okay. So what makes a good engineering product? Okay. So the most important thing is it has to be functional. Okay. It has to work. No, there's a lot of, when I was there, a lot of people said that I did not like industrial designers. Okay. It's not that I don't like them. I just think that they do a lot of pretty little things that really do not work in real life. That was why I was so much in love with Innovación y Diseño, no? Even though I'm a mechatronical engineer, because Innovación y Diseño can properly show this product, okay? I think one of the most clear things, and I don't know if you guys know this story, when I was a director there, we made a contest with different universities from all around Mexico with, what was the Nespresso? You've all had Nespressos, right? The little capsule coffee things and everything. And it was incredible. It was incredible seeing how you guys, with an engineering mindset, were completely different than anybody that's a licenciado, let's call it that way, because we love to tease licenciados. We all know it. It's like they are under us, so it's okay. Okay. So one of the most beautiful things that I saw is Nespresso came with a very vague but a very real scope. They said coffee should be this ounces, and this ounces, depending if you did which size of coffee. Okay. It has to be within this temperature, and it has to be done within this time frame. Okay. Easy. Oh, and of course, it has to use an espresso capsule. Okay. Easy, right? I bet you that right now that I'm speaking about making a brand new coffee machine, all of you guys are already imagining a brand new coffee machine. Where are you going to put the cup? Where are you going to do the blah, blah, the water? You're already going through all of those. Everybody does this, okay? The great difference between us engineers and licenciados is that we go through every single detail, okay? If you want to do a coffee, let's say in 8 seconds, 10 seconds, 12 seconds, okay? There's 2 important things that you need to consider. Can somebody tell me which are those 2 things? What do you need to do a coffee in an espresso machine? What's going to be your, that's your scope, but what's going to be the mechanical, the real life things that are going to make you difficult to be able to achieve this this scope. That we said temperature, I don't know how many degrees it was, and let's say 10 seconds to do a coffee. There's two things that you gotta make sure that you can comply with, or you gotta be able to put into your coffee machine.
Like
Anybody?
water and the coffee, like the capsule with the coffee.
Okay, so you do need those two, of course, to make the coffee, but to be able to comply with what temperature I want and how quick I want to do my coffee. Because if I have those two and I put them in a pot, right now here we're 40 degrees, okay? I put it outside. By the end of the day, I might have a terrible coffee, but I'll have a coffee. It might not be hot enough, but I'll have a coffee. But if you want to do a coffee machine, there's two things as engineers. We know the names that you need. What is it?
You need a thermometer and
Okay.
a clock.
And a clock. Okay. So those two, at least they can give us certainty that we're doing those two. Okay. But what are the machines that will work with the time and the temperature? I'm going to tell
Maybe
you one.
something that helps you with the pressure, like of
Okay.
the water.
You know what's the name of that? What
Like
puts
a
pressure?
Bomb? Oh, I don't know. Then bomba.
Bomba, muy bien, a bomba. You know the word bomba in English?
No,
English? I'll do
no,
that.
I don't.
Pump, okay? So we need a pump because if we cannot pump the water, okay, we won't be able to do the coffee within that time. If we should just do like the French coffee machine that you just put the water on top and it drops and drops and drops, I can assure you, you won't have a coffee cup in 8 seconds. What's the second one? Maria Victoria said something about a thermometer, okay? But how do we heat the water? With a heater, okay? Un calentador, right? So if you're going to design a new espresso machine and your scope says you got to put coffee within this time and you need to have the coffee done at this temperature, those are your two most important things, not the design. Because where you put the capsule and where you put the water, you'll figure it out. It's not that difficult, to be fair, right? It's 19 of us, I think. I don't know why so many, but if I would ask you to make a scratch of the coffee machine you're thinking about, they're going to be similar, okay? But they're going to be different, all of them, and they're still going to work. But the only thing is you got to make sure that the pump and the heater, you're able to put it inside the machine, right? And this was the biggest difference in this thing that we did with Nespresso. Every single university that had only a program for design for the industrial design and all of these careers that are more a licenciado area, okay, they would draw up. I gotta tell you, they were beautiful coffee machines. One of them actually, and the second year they did one that had to be for a lawyer's office, and it looked like a book. This coffee machine really looked like a book for them to put it in a shelf, and it was gorgeous. It was one of the most creative, beautiful machines that I saw. But the Nespresso people were very smart. They asked one team to attack the other team on their scope, showing them that that product was not doable. First thing, lawyers' books are very expensive, right? Okay, they have a big museum behind them with all fancy books and everything. Are you going to put something with water there? If you got a leak, is that a good idea? Where are you going to move all that temperature? Are you going to remove the machine every time you put water and then put it in again? Are you going to run the cable? You're going to move all your books, run the cable through all the bookshelf. Okay? You see how it starts becoming unreal? It starts becoming like, yeah, it's a fantastic machine. Nobody's going to buy it. Okay? But the biggest thing was nobody had considered the dimensions within the existing pumps and the existing heaters that you could use for that product. Okay? Be fair. If you guys are going to do a machine for an espresso right now or any other trade make, okay, are you going to work from scratch? Are you going to create your own pump? Your generation is going to go to Temu. It's going to do bombas chiquitas rápidas. Yes or no? And cheap. Okay. Delivery in 5 days, please. Okay. And then it's going to come like 6 of them. And from those, you're going to choose one. Okay. Hope at your moment, maybe the cheapest one, the one that has better reviews, whatever it is. But as an engineer, you're going to have to know the specifics. Like what would be important for a pump and a coffee machine? In a coffee machine, it's going to be, of course, how much flujo de agua, okay, does the pump has? How much power can it push of water? Okay, that's the very first one. But there's one that's not obvious. Can somebody tell me which one it is? Has somebody got a pump at home? Maybe for the shower, because you got to pump water to be able to have a shower. If not, you have a very, very bad power on your shower.
Yeah.
There's one thing that's very annoying about pumps. No one.
Maybe like after some time it's like born, or if it doesn't have water, they don't work. So,
that's a very important one. A pump cannot work without water because it burns itself. Okay, so you'll have to be able to put a safety mechanism there that will, and actually a coffee machine does this, that won't pump water unless it makes sure there's water in there. Okay, but there's another one. It's more a fancy thing. Pumps are very noisy. We've all heard that pump is like okay. So one of the things when you choose your pump in Temu should be low decibels, because it's important for your coffee machine, unless you're planning to do a coffee machine that nobody buys. Okay? So you can see how it becomes more complex. But now you know at least you need this pump. And this pump is this size by this size by this size. And that pump has to be in the lower part for it to be easier for you to grab the water, pump it out. Okay? So our brain starts working like this. Not, I'm going to do this in silver and this in red, and this is going to be like this, and we're going to do this like, no. We're going to be able to put this. Am I going to put the heater before the pump or after the pump? It has to be after the pump, because we don't want to have any gas pumping through the pump, and we're going to lose temperature there. So all of those things you got to start thinking about. How do I get rid of that extra heat? Okay, so all of those things is the great difference. So this is, again, understand that success is not only technical, but it also needs to be working. It also needs to be desirable. It needs to be safe. You must be able to manufacture it. No? Some people just come with these crazy ideas. It's like, yeah, we're gonna do this, and yeah. That coffee machine is gonna cost 20 grand. Who's gonna buy an espresso machine of 20 grand? You buy a proper Italian beautiful machine for 20 grand. Okay, and of course you need to be able to make a profit out of it. Okay, the only thing that I can tell you, when the profit, it's not clear that you're not going to sell it and you're going to make some money about it. It's when you're directly at the factory, and we're going to see about it. The scope is different. You don't really want it to be or beautiful, or there's a different kind of things you want to hit there. Okay. Wow, I really need to start speeding up. Any questions, guys? No. I love this. And I wrote this. I read this from a teacher from MIT, and he's fantastic. But before designing anything, just make sure, judge whether design is truly good. Okay. It can look very modern. It can look very fancy. It can look top of edge. Okay. But the pump doesn't work. Okay. The pump makes a lot of noise. It's impossible to connect the power to the energy. No, you got to remove the machine every time to put water in it, so it does not work. Right? This machine does not work. So always think about this part. especially because you all are engineers, and we're the closest to God. Okay, for everybody working in this area. So it's always like ask the Inge, huh? So they don't know about what's flow, what's temperature, what. No, it's always go with the Inge. Okay, secret for you guys: never say I don't know. Say I'll research it and we'll talk about it, because that also makes you read quite a bit. By the way, about readings. So on Blackboard, I created maybe 4 or 5 podcasts for you guys. Okay, so I would say maybe the 3, 4 first ones you need to listen to them maybe this week. It's going to complement this part. The 5th one, it's about a book that I love. I'll send you the books that I consider you need to read about these themes. But I think the first one is 20 minutes. For maybe the innovación en diseño, it's going to be a little bit same thing and everything, because it's in Spanish is diseño centrado en la persona, or on engineering perspective. Okay, but the rest of them are very real engineering issues when you're doing a product development. Okay, so I really there's a book that's called Engineering is Human. I'll send you all the links and everything. That's a book that it's a free PDF. I'll upload it for you guys. It's a good read. One of the podcasts it's about that book. Okay, but it shows you that it does not matter how smart you think you are. There's always going to be issues. So that's why it's very important to choose your team well. Okay, and never be a stubborn guy. Soberbia kills everybody. Okay, it will. People that make their mind and says, no, I want it this way because I thought about it and I imagine it that way, and all your evidence shows something else, it's going to kill the project. Okay, keep on going. So how do we know if a project is good? Any ideas from you guys? You can read it from my screen, but you can also tell me what you think. How would you start?
To make a specific use that it has a use for some things that it haven't have resolved the thing yet.
I'm complete. They call you Genaro or Eduardo?
Eduardo.
Genaro?
Eduardo.
Eduardo. Okay. So I agree with Eduardo. So first of all, if it does not solve something, just don't deal with it. Okay? It's not an engineering issue. Okay? If you're just gonna do the same product that's already there, but just gonna make it a little bit nicer, leave somebody else to do it. If you're gonna make it more comfortable, you're gonna make it more safe, more real. That's an engineering issue. Okay? If you're gonna make an earplug and you're just gonna make it with the Mexican pato del mundial, no, good for you. That's a nice thing. I'm sure in Tepito they already sell it because they're very, very quick. They're always going to beat you to those kind of things. If you're going to make an earplug that you can adjust how many decibels you want to be able to work with or eliminate, that's an issue. That's a problem. It creates you something that makes you think about how to do it. So that's the first thing you got to know. Is there something that I can solve here? Okay, if it's worth it. What's this? Well, second one. No. How does it feel? Is there an experience problem? Because it can be nobody has thought how to fix this, or it can be this thing already exists, but it's too painful to use. No, the human interaction with the part, it's terrible. Okay, or it's very uncomfortable, or it's unsafe. Okay. Third one. What do you think? Anybody? It can be any of those. I already told you about Amazon. And if you guys are smart and you want to create a product, it's great. I had McLaren people do exactly this. Go to Amazon and find a product that was a tool with the worst reviews. And it's so funny. There's so many of them. Also, there's so many of like, I got the wrench and it breaks. That's a very basic one, okay? But I've read things about a tool not working for a left-handed. A tool. It's again going back to the NASA pen, right? I'm gonna make now a pen that a lefty can use and a righty can use. Right? So those things make sure there's a real problem. Okay. This one again. We talked about this one like 6 times in this 1-hour class. Yeah, already. Okay. Constraints. What it does do, what it does not do. Okay. Hey, again, earplugs. These earplugs eliminate the noise. Good. All noise? No. Only from this decibels to this decibels. Okay? We see this? You got one of those balls. It bounces. No. So it works. Well, this is a paddle, a ball. If you're a professional tennis player, you won't use this ball. So the constraint is size. Can I use it for baseball? If I'm playing with my mates in the park, maybe yes. If you're going to play in the Yankee Stadium, you're going to look like a fool, okay? Because material-wise, it's wrong, okay? So it's going to be a lot of constraints here. This is what I told you. I messed up with this class. I did not put the limits on the restraints. I did not search that you guys didn't change your clock during winter and summer anymore. Because when I lived in Mexico, we did. And I assumed that something of that was going to happen. Okay. A good design is also has a specific user. Okay. I want everybody to use it. False. There's very few products that everybody's gonna use. No, you gotta. Most of the time, you gotta do. I want people between 18 and 25 to feel attracted to the product, although everybody can use it. You see the difference? Like AirPods and everything, everybody can use it. Right? Big headphones and everything. You think they're designed for everyone? For a kid of 6 years old and a 65, 80-year-old man? No. Who's your target? Who's going to buy them? These ages. Okay? That's what you got to do. Be able to always start making your problem smaller. Because if you make it very wide, it's going to be very difficult. Okay? Specific environment and use context. This is very, very tricky. No? Have you guys ever traveled to Europe, Asia, something like that? Plugs are completely different. I should have a plug here. Well, funny enough, I don't have one from Europe right now, but this is for England. This is for England. This is for you guys. Okay. Then, I don't know if somebody knows, but power-wise, they're different too. This in Mexico, you guys use 120 volts, right? 120 volts, 110, 120. Okay. This one is 200, 240, depending to 20 most of the time. Okay. So you gotta be able to create a product that's standardized for. Okay. Another thing. Is there any mechatronical engineers in this class right now? Industrial engineers? Good. Maria Victoria, Eduardo, Sebastian. Okay, so Sebastian, are you Sebastian or Alejandro? Oh, there are many of them now. What do you prefer, Sebastian or Alejandro? Oh, your microphone
Yeah,
working.
but I mean, I don't have like any issue.
You go by both of them? Okay.
Yes,
So-
I mean, system, but I don't have any issue if you call me.
Okay, so tell me, have you been to Europe or Asia, uh, Australia, something like that?
Yes.
Okay, so you have to buy some of those whenever you travel, right?
Yes.
Okay, so there's three things in electricity. One of them is going to be very tricky for you to know if you're not an electrical engineer, but from this outlet, you cannot see it because it's below my TV, my screen, but there's two things in power. So can somebody tell me which ones they are? Like when you buy a battery for your whatever it is, your PlayStation controller, that one is really rechargeable. So you ask for a battery with what? Two things.
Voltage and
Correct? Correct.
voltaje y amperaje, no sé.
Okay,
English.
voltaje y corriente. Okay, voltage and current. Okay, so voltage in Mexico 110. Current, it depends on what you want it to be used. Okay, so when you buy this Chinese charger and you try and charge your MacBook with this charger, it's going to take 5 days and 12 weeks because this is only 0.5 amps. That's all the power it can drain. Okay, so it's if you multiply it by 110, it's going to be very low power. If you do a proper Apple one, they're very expensive and blah, 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 blah. That's a failed product, by the way. We'll talk about it. Okay, it's going to give you a lot of power and you're going to be able to charge it quicker. Okay, and there's the third one. It's going to be difficult for you guys to know if you're not an electrical guy, no, but it's the frequency. So a very tricky one, it's like you go to Dubai and Middle East, they use 110, okay, but they use 50 hertz, not 60 hertz. So if you don't have this knowledge or you don't research this knowledge, no, your environment is not going to work. If you design a machine that's very specific to use this charger and this voltage, it's not going to work in Europe. It's not going to work halfway world. Okay, so you can do a couple of designs in your electrical part for you to adapt it to all of them. The easiest one is a USB, because after this has transformed to 5 volts, it doesn't matter where you charge it from. Okay, so this is a great idea because this part deals with this. Okay, but after this, you're charged. So that's the kind of things you're going to start doing in an engineering thing. Okay, another one I really need to start getting quicker. Your target cost. This one in this class is going to be very difficult for us to discuss because I'm not a marketing guy. I'm not an expert in that part, so I cannot tell you which are the proper costs and everything. And it gets very, very complex because you got to study. Like if you're going to send it to another country, taxes, importation fees, blah, 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 blah things. So I cannot really help you with that part, but we're going to speak about it a little bit. Where and how you manufacture the parts. That's one of the most important things, okay? What materials do you use, okay? And how long do you expect it to work without it needing to be maintained, okay? Or just break up. Most of the things today are designed to crash and destroy. So the last podcast I sent you guys, it's from a book. It's called The Waste Makers. It was written in the 60s, and it's incredible. You got to read it. It's really, really good. I'm from the 80s because I've been speaking a lot of the 60s, so just want to put it out there. I got a white beard, but I'm not that old. Okay. There's a couple of things you got to be careful. I call them the tramps. Okay. So just be careful with it. If you have a product that you're designing to be able to put it out, just because you add electronics, it just doesn't make it better. Most of everybody that has an issue, like right now, I'm guessing you guys have a nice new fancy car, okay? And the AC now has to be controlled on a nice, beautiful screen, right? So you want to put the AC colder, you want to put the AC blow faster, you go into your screen, it shows you the beautiful car there, you select which outlets you want to do, and you put more, less, okay? And you do the same with the traction control, and you do the same thing with the internal lights, and you do the same thing with the radio, and you do the same thing with your Apple car thing, whatever it is, okay? What happens when the screen goes dead? You're done. You cannot even adjust the AC. If the radio is playing a song, you'll hear that radio song forever. Okay? So sometimes a mechanical option, click, 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 to turn on and turn off the AC, it's way better. I can tell you. And it can even be cheaper. Because although we're going to see how to do PCBs and everything, okay? Even though that's very cheap and very easy, you got to go through the design, and components are very cheap normally, and they fry, okay? And your product will get a bad review because it did not last 2 weeks. If you go through a mechanical thing that goes clack, 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 okay, like for a fan, that thing has been doing clack, clack, clack for 100 years. So that design has been tested and tested and tested, and it's going to work, okay? Always be more useful than impressive. I would say those kind of things. For an engineer, it's more, again, well, does it solve a problem to make it better? Does it reduce the risk? That's a very important one for us engineers. Again, it's make sure that there's no risk. We cannot harm anyone, because we were talking about voltage and current, okay? So I know you're a different generation, but you all seen the original Jurassic Park movie, right? The original one with the park and everything. Okay, so there's a sign where it says, be careful, 25,000 watts. No, I don't know if, I think it's volts, 25,000 volts, you remember? And little Timmy, the blonde guy, goes, la la la, and starts climbing up, and then the guy that want to kill Timmy just powers up the switch, and Timmy goes fried and flies off the fence. You remember that part? Okay. Question for you guys. Should Timmy be fried and dead? It's 25,000 volts. A square battery, it's 9 volts. Your USB charger is 5. 25,000 volts. What do you think? Was Timmy lucky not to die? I don't know. Good, bad answers. What do you think? Yeah, yes, no. Just do this. I see you guys don't like to speak. So, who thinks Timmy should have died? No. Who says Timmy should not have died? Come on, I want to see. Ooh, too many of them. Ooh, somebody said exploded. Double exploded. Okay. So no. You can grab a cable that's 25,000 volts and smile. Because the power in electricity is in the current. And this is very important for you guys to think. Okay? 25,000 volts will not kill you. 1 amp will. Okay? So if you do this and put it into the socket, okay? Well, because the reason why your breaker pops out, okay, and your power, you got to go to power box and move the switch and everything, okay, is because you required too much power and the cable was getting hot. You did not increase the voltage, because we already spoke about this, right? It's 110, 220 for me, okay? It doesn't change. Not because I connect here a fridge or my iPhone, it's going to request more voltage or more, right? It requires more voltage, right? A bigger engine requires more voltage, okay? So that's going to kill you. So if you decide to make a charger and you want to make it really, really quick, and you do it, it comes through, if you do the reading of your charger, it says how many milliamps, no? An hour it gives you, that's power now, okay? So milliamps, if it says 200, is 0.2 amps. Okay, good? With math, everyone? Okay, so it's going to give you 0.2 amps, and you're going to be charging your computer really quick. If it has, I don't know, this might be a crappy one, It does not even say. So this says this one works up to 1.5 amps. Exit for 12 volts. So this is a fast charger one. Okay. What happens if I'm able to stick my fingers in there? Now I'm Timmy. Okay. Now I'm gonna be in quite issue. I'm gonna be in hospital maybe. Okay. And you guys are gonna get a lawsuit. So be careful with those things. Okay. When you're searching for engineering things, always put safety priority. And one of the podcasts that you're gonna hear, it's everything about how our mind has to work regarding those kind of things. Okay. This is another one that's very important. They can be manufactured consistently. So in Mexico, we talk about a lot when we're doing the science that it's, how you say it? La tolerancia, no? So everybody puts in drawings like, oh, what's your tolerance? Plus minus 0.1. And we feel very engineers, and it's like, yeah, I'm very good. That's gonna work. No, that can be very, very expensive for something that you really don't need. And 0.1 might mean nothing. Okay, if you don't 0.1 millimeters in the length of the wing of an airplane, it makes no difference. No difference at all. If you have a bug sitting in the at that wing, it's already that difference. Okay, if you got to make those little ones in a track for a PCB, it's going to mess it completely. Okay, so learn to do those. We're going to kind of do those kind of things. Okay, so I'm just going to put those. Okay, so remember we're going to be working on the other end. Okay, so one of the examples I put here for start talking about this is if you start designing it for it to be very, very nice looking, elegant, it feels good, no, it's beautiful. But the cartridge, the one that we put in the product that you're going to put in on your body, leaks, jams, or it's very expensive, it's not going to work, right? Who wants to buy something that when you put it in, you get all sticky, no, and then you put it in and it breaks, or you put it in and it starts leaking somewhere there? So those are going to be some of our priorities. Okay. Next one. Common mistakes. I'm going to go kind of a little bit quicker on those because I think most of them we can relate to. Materials, they're not strong enough. They do not have the proper fill. They're very costly, no? Or you're going to start seeing those products you cannot recycle. Okay, so I'm going to give you a tip, and for everybody that's waking up, still wake up, because that's going to be probably in one of your last assignments. There's a tax for bringing plastic into Europe that you cannot recycle. So it's just going to make it way more expensive. Okay, so those kind of things you need to be able to learn how to do it. Okay, the mechanisms. This one again for this course is a little bit tricky to go through all of them, but how they move, how they lock, how all these things mean. If we don't speak about those and they don't work, and you don't do a fatigue test that you open close like 100 times or 1,000 times, it might fail on you, and it's always going to fail in the worst part. We will not see this part, but this part is very, very important. How you pack it. Okay, we'll just talk about it very briefly, but one, it's how long it can be in the shelf, how many can you put in a container, which materials are you going to use to be able to secure it, and how much material do you need for it to be safe. Like in the US and in Mexico, if you buy a TV right now to see the World Cup, it's going to come in a nice cardboard box, right? But inside you still have unicel, right? It's very messy. It sounds horrible. You put it out, but it's kind of safe. It's very, very cheap, no? But the first TV that was sold that way, that unicel is still out there. And it's still going to be out there for 300 years. Okay? So if you're going to sell a TV and you're going to say that your company's green and you're selling it with unicel, that's not going to go. TVs here in Europe, that unicell part, it's cardboard in different shapes, in different places, for you to be able to constrain the TV without it moving or without it breaking, but without using those, because cardboard is 100% recycled. Okay, so those things you need to think about. Okay, tolerance, we already talked about it. There's different ones. We're gonna speak about if it's a fitting, if it's assembly, if it's a quality control. How do we do it? How do we test it? No, there's a lot of things we can speak about there. And then when you're designing something, it's if you're going to require it to be maintained or not. Okay, if like a coffee machine, you got to do the calcification, no? So we got to put something there to clean the pipes. Okay, so those kind of things, how easy we're going to do it or not. Okay, so we're going to have two kind of products. Okay, and now I'm going to let you guys read the two, well, this one, and then we're going to change this one. And I want you to give me some examples that do constrain all of those. Okay, so for a commercial product. So a commercial product is everything you go, like an iPad, the controller for your PlayStation. I'm just saying things that I'm watching it, a toy, a lamp, whatever it is. Okay, so most of our priorities are already there. There's some examples for the other end and some common errors. Okay, so I would like for you guys to think about it for a second and tell me one product that's out there that does not comply with something from this from this sheet or from this screen, because there's a lot of bad products out there. I'm sure you have purchased one and say, this is crap. Think about it. Give me a bad product.
A bad product?
One bad product.
I don't know. Like, for example, for me, one bad product was it was I don't know, let's say recipient or lonchera just for a banana. Like it has the shape of the banana, and it was only for keeping the banana safe, and I don't really get why. But yeah,
Wow. Let me get this one right, Eduardo. It's like a Tupperware to put a banana inside.
yeah, and it has the shape of the banana. It's only like the banana shape, just to put only one banana.
Okay, so I would kind of agree with you. Why it's a terrible idea?
Because unless you work like on construction or something like that, the banana it's safe on any kind of bag you would keep the banana on, and I don't really see why you should have a specific topper for a banana.
Perfect, Eduardo. So we're gonna go back. We're in sheet 10. Where is it? They made a huge mistake and you just nailed it. Where is it? I think I never spoke about it, but it's for who it is designed for. The user. It's somewhere there. We already went through it, but okay. So the user, it's unclear. I completely agree with you, because you mentioned a construction site worker, right? Anybody think of let's say it in Spanish, un albañil with a Tupperware to carry their bananas? You think an albañil wants to buy that? I cannot imagine. It's like, yeah, I brought my banana. Then you peel your banana. It makes no sense. It's a bad product. No, I'm sure it's not really out there. It's not like it made a lot of money. Somebody just created one. Maybe it was a school project. They just went through it and they just built a couple of them and sold it out. But Eduardo, I would completely agree with you here that the user, no, it's terrible. It's a terrible idea. Which other bad products do you think commercially they are?
Well, I'm thinking about the thermoformed packaging of
Okay.
toys. Because when I was younger, like every time my parents bought me a Barbie, like it
Mhm.
was so hard to open. Like I had so much trouble, and every time I wanted to cut like the package to open it, like my hand
Remember
hurt.
that.
And like it was also kind of dangerous because I cut myself sometimes. So I think because it's toys and like kids usually open it like their toys, it's like not really easy for them.
So that's a very interesting, uh, Adriana. So that's very interesting because it's a two products. Actually, the packages makes it a good product, a bad product, or a risky product, not even a bad one. Because to be fair, if one of your parents who had opened the Barbie for you and handed it to you, you might have never had that experience. But I think everybody here had that experience about in my I'm way older than you guys, but I had a Teenage Mutant Ninja Turtle and everything, and it had some of those wires to strapped into the cardboard so they wouldn't move. And so it was frustrating. You wanted to play with the toy and you were this, and then you were pulling, and it was cardboard that was laminated, so it would even make it harder for you to be able to remove the toy. Okay, so here you're making a good product because the Barbie is a good product. It's sold for so many years, and there's a lot of people that are very excited about getting a Barbie or a new Barbie or having their first Barbie, whatever it is. But their packaging makes it a bad product for the user experience. But for transportation, it makes a great sense to do it. Because if you're Barbie, and we've all experienced this, we've all gone to McDonald's and we've seen the picture of the Big Mac, and then we have received a Big Mac. Nothing to do, right? So imagine if your if your packages for your Barbie that you're paying a premium price, not a mercado price for the other Barbies, okay? And the box already looks like the real Big Mac, right? It's like when I love Hot Wheels, when the box is already kind of broken and everything. It's like there's the same exact car, but the packaging is perfect. You always grab the perfect one. You're gonna open it, doesn't matter, but you want the full experience. Okay, so that's a very tricky one because there's a premium package in a product inside, a terrible experience for the user to open it, but a great experience or a greatly built product to be able to transport the Barbie for it to look perfect from wherever it's built into the Walmart or the Toys R Us or wherever you buy your products. So that's a very complex issue, but yeah, it is. It can be a user experience bad product. Anybody else? There's a lot of them. I'm actually trying to find some on my desk.
Probably will be the Siri remote for the Apple TVs.
For the Apple TV,
Yes, like the remote that Apple designed.
it's
The-
terrible. This is the good one. This is a little bit. Rafael, I always use this example. It's funny. You're talking about the previous one. The one had like a black frame here that
Yes.
you touched it and it moves. It's impossible to. You gotta have clean your finger and do this to move it, and then I drop it twice, no, and it breaks, and you cannot replace those parts. It's a terrible remote control. I completely agree with you. Uh, I always use that example, and I could not remember where my bad control because it's broken somewhere. But I always have it on my desk when I do this conversation. But I fully agree with you. Apple TV
Tony.
controllers are probably the worst. They overdid. Remember the last shade that we spoke. Never overdo something unless it's critical for your product. If your scope says create a controller that has a touch screen, okay, that's your scope. But you got to make sure that it's not as sensible that it's going to frustrate your client. Because if it's frustrating, everybody started work using your phone to be able to control your Apple TV, or just stop work using your Apple TV for other things. Great example, Rafa. Somebody else, one more. I think you guys are growing old. You guys need a break. Come on, one more example, a couple of shades more, and we can take a break. Who has another bad product? I'm going to show you a great product. As you can see, it's cheap, easy. Does somebody know what it is for? I'm going to show you the name of it. Have you any of you lived in the US? It's a stud finder. Has any of you lived in the US? No?
No.
No, no one? Okay, have you seen how the US builds houses? So we use bricks, right? We do the columns with la varilla, we put cement, we put bricks, and they're done. I'm sure you guys have seen how American people do their houses. Can somebody tell us?
With wood, right?
With wood, correct. So they put wood parts, and they just put some panels on top of it, right? That's how it's built. That's exactly how it's built. Okay, so I was gonna show you a picture, but that's how it is built. So the stud, when you wanna, the issue in the US is like, this is solid wall. Okay, so if I want to hang a TV, I can do it anywhere, right? I drill a hole here. Well, maybe not here because power lines might come here because I got a power cord here. But I can do 4 holes here, mount my TV, and I'm happy and pleased that I have a TV there, right? In the US, you cannot do this because like it's only cardboard. Both walls on both sides are cardboard. Cardboard cannot hold a TV. So you need to find the wooden bin. It's called a stud. Okay? So the issue is in this wall where the stud is. So there's a rule that has to be 12 inches apart from each other. But where does it start? Where do I start to count 12 inches? Okay? So you can buy, most of the professional people have like a small scanner that you put against the wall, okay? And it shows you, it has an infrared, so it bounces on the wall. If it goes deeper than the wall, it knows there's nothing behind it. If there's a wooden bin behind it, it bounces back. So you know there's a wooden bin there, okay? You can imagine those parts are not cheap at all. No? It's like a little X-ray. What do you think this thing does? What do you think this is? No idea?
No.
I'm going to give you a magnet. Why do you think it has a magnet? Because to be able to put that beam there, what did you use? Nails. Nails are made of metal. So the only thing you gotta do, I don't live in the US anymore. You just do this around the wall and then it gets stuck. Why does it get stuck here? Because there's a nail there. And you cannot put a nail through cardboard. You can only put nail through give me 1 sec, guys. Dog woke up. Okay, so this will find you the bin because it knows where the nails are. Great idea, isn't it? Cheap, easy, works every single time. Okay, so let's go one more. An industrial product. The difference between industrial products and commercial products is, again, industrial commercial products needs to be nice, need to be affordable. They got to have this nice textures, proper wrapping, transportation. For industrial products, we don't really care if it's nice or not. The most important thing, if it's safety, how quickly we can place it in, and how low maintenance it requires, to be fair. If you're going to design a part for a machinery, those are your critical parts. Because we've been speaking about solving an issue, like if we're going to create a new product, and we are in this course. But if you can follow this same logic and all of these steps if you want to build a new machine, or you want to add to an existing machine a new process or a new control. Okay, let's say if you have a machine, that I work with a lot of machines, especially in the US, where a gear always fails after 10,000 cycles. Okay, what can we do to make those 10,000 cycles 100,000 cycles? Or if this gear takes us 3 hours to change and recalibrate, how can I do it in 2? That's what it's going to pay, and it pays a lot of money. Okay? If you see most of the rich people in the US that are farmers, are because they came up with an industrial idea of how to make a farmer's truck, or what is it called, a tractor, easier to work, or to make the hole easier in the ground. I might just be adding a cuña or doing some small things because it makes it better, it makes it easier, it makes it safer. Okay, so those are also things that we need to be able to address. Okay, you guys, especially if you're going to be an industrial engineer and you're planning to work in well, I know it's not that it has to be, but some of them you might be planning to work in a factory or controlling quality or those kind of things. This part is really important for you to be able to address. It's like, how long does it take us? How long can we change it? The product I was telling you about that we work with McLaren, it was 2 tools to make our scope, original scope for it. It was to reduce at least 40% of the time that it took us to remove a part in a car. So imagine you got a screwdriver and you remove a screw, put it in, it takes you 1 minute. We wanted to do it under 40 seconds. Okay, so those kind of things will pretty well pay for you. Okay, if you guys really want to work in like an industrial product design, this is going to really work for you. Okay, so again, some of the common I didn't go through the common errors on the other one, but well, it's funny enough, we talk both kind of it, making it more beautiful than it needs, ignoring the packet until the end, over engineering. That was a remote control for the Apple thing, bad materials. And then, by the way, I'll share this presentation with you guys after every day. Okay. Most common errors in engineering is making difficult the access to some of the parts. Have any of you like working on cars? Have you ever tried to change the oil filter in a BMW? You'll know what I'm talking about. It's crazy in some of the models. The E23 is the worst. This one, if there's any industrial engineers here, ignoring downtime that one replacement takes. If you have 2 machines and you need to do a production and one of the parts needs to be changed, and every time that you have to change that part, you need to put the machine down for 2 or 3 hours, you have to do overproduction in another machine. And that means that one won't last 10 hours. It's going to last 9 hours because you're switching the production in times. So be very careful about that part, okay? Okay, guys, so I see some of you, the very few that have your cameras on, then we might need a small break. So let's take a small break for you. It's, I was gonna say 6:39, but I don't know what time it is. It's 10 o'clock for you, probably 10:40. So let's do a 15 minutes break, okay? So 10:55, I'll be back, okay? We can do that also in every class. We'll see if a longer pause in the middle works for you guys, or we do two smaller but ones for, because I know this is a lot of information coming from one side to another one. And then in the class, you are going to be working with each other. So yeah, it's important for you guys to be a little bit more brainly active. Okay, if you guys have already done teams, you can add it in the chat. I think there's a chat for you to say, I'm going to be working with this guy and this guy, or these people, and I'll start working with those teams, so we can move a little bit faster at the end. Okay. So so guys, I'll see you in 15 minutes. Okay.
Yep.
Take a quick break.
Thank you.
Yeah.
Okay.
Hey guys, are we ready? Good. Let me share again my screen. I'm missing some students. Oh. So guys, this is what I've got. So these are all the students I got. I see some of them on the chat that are not here. So if you're not in this list that I can see, please get in touch with Isa Castilla, and ask her to add you in the class, because I have no idea how to do it. And yeah, it's going to be quicker for her to do it. Okay. So, sorry. So this is where we were. Okay, guys. So again, I did this small one for you. So doing the compare between a commercial and industrial, in some parts that has both of them. I think we've spoken quite a bit about this. So again, most of the time, commercials are going to be very beautiful products, and you need to make sure that they're correctly used. As very well we commented that we have to have a good user experience, like the packaging that we were just told about. It has to be aesthetic. The price and the packaging has to be good. Otherwise, in the industrial one, it has to be more reliable, safe, and low maintenance. So for all of the parts, okay. I think maybe from this sorry, I need to turn on the feed. I would really think more about the risks. So that in case of a commercial product, the beautiful product that nobody buys, that you got to be very careful about it. It's very difficult to know if people are going to buy your product or not, but you can kind of find some information before you really launch it. We're going to see about it. There's a lot of data there of what kind of products are being purchased, what are what are the tendencies regarding some geography areas or ages areas. We're just going to scratch the edge of that topic. There is a lot of information out there that you can become a professional about it and really learn how to do it. Of course, in an industrial one, it has to work. But if we really don't understand the function of that part, it is going to fail, or it's just going to make it more difficult. Again, so I'll say it in Spanish to be very clear. Soberbia always kills a product. If you are keen as like, no, this is how I understand it, this is how I would do it, you're going to have an issue with the product. The best way for an industrial one to make sure that it works is that you really understand, and the best way is to go with the guy that's been working on that machine for 2, 10, 8, 20 years. Those guys know everything about that machine, about that process. Okay, that doesn't mean that that's real, because most of the time, people that have been doing the same thing for many years, they tend to have their own vision of how it should be done or how they would like it to be done, and of course, you want to improve it. No? I wanted to show you I got tons and tons of tools. So everybody knows this spanner. ¿No? Llave combinada en español, hubiera sido una llave española o inglesa, cambiando this end. Okay, so this is a basic tool. We all had it, we all play with it. Why is it blurry? Okay, so we know what this is used for, right? You got a knot, you got to tighten up on here, no? And then you got another knot here, and you can use it without it. Because on this one, you got to connect, disconnect, connect, disconnect, and this one you can kind of do it in an easier way. Let's say it that way, okay? But somebody redesigned this tool and this tool, okay? So you can see it's basically the same thing. It has two differences. One of them, you can see this, you can hear it. So now you don't really need to disconnect. Once that you're in, you can go back and forward, like I'm going to say it in Spanish again, a matraca, no? Just to make sure that we all know the tools. But you can see you can also work into an angle. Okay, so maybe the typical area that you can kind of need to get in there, but it's in an angle, but you cannot really go in a straight angle because there's maybe a pipe or some other part here. You just need to go into a small little angle to be able to tighten it. That's a good approach. No, again, it's a new redesign. Then somebody did this one. Okay, so again, original tool, first change. You can see this part. Somebody already connected the links, okay, but they only did it for one size on one end and one other size on it. Great difference about this one is if you want to tighten it, you got to use it this way. If you want to tighten it, you got to turn it around and reconnect it to be able to connect it the other way. You can see it. It only spins that way. I kind of spin it this way. Okay. On this one, you got a little label here that you can change. Okay. So once that I'm connected, I can tighten, I can untighten. Okay. Maybe it's a better tool, maybe it's not. It's already pre-designed in angle. Okay. Then somebody came up with this crazy idea. Okay. So in this one, you can see that you got an angle here that you can change, and the teeth change. So when I tighten it, you can use different, you can set it to different sizes of knot. You can see there that's a smaller knot. I just do this, tighten it again, you got a larger knot here. Okay. I think this is more like for those, let's say, handymans that you want to go all the way in the top of an antenna and you want to make it change, but you're not sure what size of a spanner you need. So you don't want to bring 6 of this, or no, you can just bring this one up and kind of access it. Of course, if you have a top access. And then not far long ago, I found this one. It's kind of a pocket knife. So it's a little bit more pretty, let's say it that way, and you can see it kind of adjusts to the size of the knot. Okay, you can move it and change it. Okay, I'm not saying all of these are successful designs, but they do all kind of clearly. You can see that although the function is the same one, it's this one, we really didn't need another one. But when they went through their scope, they had an issue, and they were able to find an issue that said we could make it better. In this case, you got to connect, disconnect. So now at least we can make it easier to rotate. Now we don't need to disconnect to be able to change senses. Now we do not need another spanner to be able to change the size. No? And let's say a combination or an extra design of this other one, very slimmer. You can say this, you can imagine this is way heavier than this. Of course, it also gives you almost the same amount of knots that you can work on. So it might be a better design. Okay, I don't know if you can use the same loads. Those would be something that you have to read about it. But I just wanted to show you like some of those different approaches to something that's already solved. So something I also wanted to tell you is, just because it's already been solved, don't assume that that's the final design. Okay, there's something else that can be added to. So I wanted to tell you about some of those. If you've never heard this podcast, it's pretty good. It's one that's called How I Built This. It's a guy called Guy Ross or Ross. Okay. And way before, in 2029, he interviewed the guy that created the Dyson vacuum cleaners. I would recommend you to hear it. It's not part of this, but if you do like podcasts, if not, at least you're going to listen to 5 or 6 during these 3 weeks. This is also kind of worth it. This is a very particular issue. He goes through how he was able to make Dyson the new kind of vacuum cleaner, because before him there was all of this horrible bags that you would have to put in. They would get all the dust inside. They would not work properly. He was able to redesign and remodel our brain, because now every single vacuum cleaner looks like a Dyson or works like a Dyson. So how all of this was turned into, and how was he able to do it? To be fair, when you hear it, you'll see that he had a huge team, and he had a lot of resources to do it. So most teams do not have that amount of time, that amount of resources, and money is one of the resources, but also experts and team members working with him. So yeah, that makes it easier if you want to see it from one point of view, but it's also, it doesn't make it doesn't make less of his achievement, although yes, it's a very particular issue, right? It's something that maybe NASA would have with that infinite resources. He does talk about when he started struggling with money and everything else, but he also wanted to do all the issues himself. So I think it's worth it for you to hear. But regarding this, is like, this the vacuum cleaner and an industrial pump, these are the best, one of the best industrial pumps there are. No? They work exactly the same. You want to suck something and put it into another place, okay? But they're completely different. If you want to design for a commercial, you cannot use this kind of pump because of the requirements. Again, we said about noise, power consumption, weight, not all of those. If you want to do it into a commercial one, but if you do as a pretty one, like the vacuum cleaner from Dyson into an industrial system, it's not going to work either. Because it's not going to be reliable enough. Okay, it might not work with a three phase energy. So all of those things you need to take into account. Okay. The funny thing is, again, it's a pump that has a different function. So they share a lot of things. So when you're looking, whenever you're going to start looking, it's going to start probably tomorrow or the day after that, for different products that relay to yours. In this case, the deodorant or your own project. Don't only think, if you're doing a vacuum cleaner, don't search only about vacuum cleaners, because it's going to be, if Dyson had searched this kind of vacuum cleaners, he could have searched nothing. There was nothing in the market. But he had to search what kind of pumps they were, what kind of vacuums he could create. So if you extend it and you look into other areas, you'll find some very interesting information, and you might find a patent that blocks your progress. So that's why it's very important to open the scope of your search. Okay. Some key concepts that you need to remember from this first day before we jump into a more workshop area for you guys. It's technical functions versus product success. I would say not everything that you tested in the lab is going to work out there. Okay. When you work in a lab and you've done a bunch of laboratories in your engineering career, and even when you did high school and everything, you got a very controlled atmosphere. So you do this, a teacher shows you how to connect the wires, you do the connections, it works, it does not work, you do the testing. Once that it works, you make it spin. No? I remember when I was there was a physics lab that you would take in first semester. I don't know if you do it anymore, but we would connect a bunch of things, and we would use lasers to run through glass and mirrors and those kind of things to see how it deflected. All that's beautiful. It's very easy to do, to have a calibration. Once that you use lasers to be able to read a DVD or something like that, and you're planning for it to be moving, it's way more complex than just working it in a lab. Okay. Well, this is very important. The product keeps the promise that it is used for the real user. Okay. Remember that you're saying, like we talk about the headphones. If you're gonna use you're gonna redesign a headphone for a market between, let's say, 18 to 30 years old. Okay. Everybody within that area needs to be able to use it without struggles. Okay. And that's why you gotta, again, scope it correctly. You guys have tried to teach computers to your granddad, or every time that your granddad messes up the printer or something like that, it's a headache because you're outside your scope. Okay. But for the people of your scope, it has to work as promised. If you said it's going to cancel noise, it cancels noise in the airplane, at the racetrack, in a classroom, at the subway, everywhere. Okay, so those kind of things are very, very important. To be able to be sold at a price that's almost logical. Okay, if it does not create any kind of risk. Like I think it was Victoria or Adriana was telling us about the nightmare of the Barbie. Yeah, that cannot happen. Today it's way more difficult than when we were kids. Right now we've got social media. People will show their thumb bleeding, and your product can go to hell just because of that. Okay, this one, it has to be very easy to use. I can bet you that if we did this, if you have never, and this if you always, we will get only thumbs down that if I ask you, have you guys ever read an instruction manual? Never. I can bet you never. Jaime has. Good for you. Oh, Sebastian has. My God, we got 2 out of 20 now. Instructions manuals are it's a difficult topic because it's a requirement for you to be able to sell a product, but most of the people were going to work with it as ever they think it works. Okay, they're going to plug in the printer and then boom, connect this wire here, and it should work. They don't go into the manual unless they got an issue into it. But you got to make sure that before they have an issue, there's no risk, safety issues, and they might not ever go to your manual. So it has to be very easy to work out. Okay, your product has to be if it has an assembly. So now you should be thinking about your deodorant. How I'm going to put the cartridge into the deodorant without it being complex. Okay, if you have little screws that you got to fit in there, or you got to put a little thing that you got to push up and then put it in and then push it in, it has to be kind of clear to be able to do it. But at the same time, if you got to push it out, remove it, push it in, and then click it in, if somebody fits their finger there and then clicks it in and they cut their finger, you're going to be in issues. Okay, so those kind of things you always got to think about it. It's because this part of incorrect use, it's always going to happen. No? In Mexico, we say that you got to design a prueba de tontos. Always think about it. There's somebody that's going to try the most impossible way to do it. I've seen people try to connect an HDMI into a USB port. No, it's like if you never went to kindergarten, you can see that it does not fit, but they still try. Okay, so be careful with those parts. Okay, the manufacturing part, it's very important that parts fit, that you do have suppliers, that the material is available, that your supplier can meet your requirements for tolerance, quantities that you need delivered, because most of the time when you're doing a prototype, they'll always do it. But when then you need I only need 12,000. Okay, it's going to take me 6 months. You cannot wait 6 months for one part, or probably you can. But those kind of things you always need to do. And also beautiful geometries, not enough. This is a difficult part. Right now, there's so many new manufacturing technologies like 3D printing, powder manufacturing. It's incredible what you can do, because powder manufacturing, it's incredible because you can do very precise parts and very complex parts. And it used to be very expensive because making the molds was very expensive, because you need to do a CNC, you have to do the drawings, do all of these things. Now the molds can be done on a 3D printer, and it can be done overnight. And then you might only need to do a little rectification on a CNC machine. So costs for those kind of manufacturing has gone down 90%. So it's something like if you're a mechanical engineer or design engineer and you really want to get into those kind of parts, powder manufacturing, polimetalurgia se llama en español, it's something that you really need to look into, because it's something that's really there, and it gets really nice and precise parts. Like all those parts, like for your watches, they're all done like that, powder manufacturing. Okay. How are you going to maintain it? Again, low risk, and if it's sustainable, if you can really cost it out. Remember, there's a lot of regulations. We already kind of touched about it. If you're going to do exportation, so you're going to move it to another country, you need to know which are the limitations for that country, because you're going to face some penalties if you don't do it. Okay. Some common mistakes on this first area. The first one, I think, I said it more than once: falling in love with the idea. If you have the idea that it's going to be blue, and it's blue, and it's blue, and it's blue, and it's blue, and you don't hear and you don't research and you don't, and you keep on going blue, 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 or design-wise, and Barcelona diseño people might really know this. If they go through their first prototype and they just go through it and throw, is not going to be the best of your prototypes. You always got to start changing, play with it, and be able to make a difference. No? Design for oneself. Remember, you need to, unless you're 3D printing for something that you need at home, no, you're not designing something for you. You got to understand your market. You got to know who's your target. No, those kind of things are very, very important. And again, we're going to see how you can do it, but you need to be able to know how big that market is. No? If they're really interested in that product that you're doing, because maybe you think they are, but maybe you just need to move your scope. Maybe their scope's a little bit older, or a little bit younger, or it might just be non-existent in a geographical area that you're planning to launch your product. So that part is really important. Again, and don't get into I fell in love with this idea of it having this. Don't do that, because it really creates a lot of issues within the team when you start working on it. Ignoring production. That part of it's like, yeah, we'll see later how it works. It never works. It's going to create a lot of headaches. It's going to destroy the original design that you have created for your product, and it's going to create a lot of issues for your team. If you're the product, the manager, leader in that product, you're going to have too many issues, and they're going to ask for your resignation. I can tell you that. It's, if you don't have an understanding of what can be done and what cannot be done and what should not be done, no, it's going to become very difficult. No? And very clear, and make sure what you define like better without metrics. Okay, if you say, so this remote control needs to be able to change the channel 1,000 times before the battery runs low. That's a very clear metric. If you want to say the remote control has to last 6 months, that's not, there's some big issues there, because if the remote control is used every single time, every 5 minutes, it's never going to last 6 months. If you just need the battery to run in a standby for 6 months, that's again a very clear metric. Okay, I want 5,000 clicks, or a maximum of 6 months, or a minimum of 6 months in a standby. Those are very clear metrics. Don't write it like the battery has to be last for very long. Those are poor metrics. Okay. So how do we evaluate one of these products? Again, who needs it? If we have a real problem, who's going to use it? What are our constraints? What is going to be their function? What evidence do we have that we need it? Okay, and then we make the decision if it's good enough or not to produce it. So let's retake the example from NASA. Okay, need. Is there a real problem? At least writing in space, there was. Okay, creating a new pen, there was not, but there was a real problem. We need to be able to write in space. Who was our user? Astronauts. That was very easy for us. Okay, what were the constraints? No, that's where they went wrong. Okay, their constraints, again, it's going to be the main part in a failing on a project. If the constraint is not clear, here's not a cost or a norm. It was, what do we need to do? Again, we go back to your real problem. The real problem is write. Be able to write in space. What they did was fight against gravity. Somebody, when they were talking about the problem, they said, we cannot write because there's no gravity in space. And they erased everything from their mind, and they only thought about gravity in space. Okay? So that part, you really need to be careful. Okay? Constraints. What it's going to do, what's not going to do. The function. Okay? What are we certain that we need to deliver? Okay? It's going to be a pen. So it can, this we consider a pen. This we do not consider a pen. Okay? Because it has to be able to fit in your hand. That's within the understanding of a pen. If you say that you're going to create a device that writes in space, that's no longer a pen. Okay, so it does not have to fit in your hand. It can be another kind of product. Okay, so be specific. Evidence and data. Okay, we're going to go through patents and all that. It's a lot of information, but you need to be able to search about it. I'm going to tell you one thing. I'm jealous about you guys because with AI, it makes it so easy. So for the 4 patents that I worked with, for the first one, it took us maybe 8 months of reviewing patents. And you're going to read one because I'm going to give you one to read and you're going to tell me what it is about. And they're very complex. They're like an engineering patent. It's in between. I don't know if it's still a thing, but when I lived in Mexico many years ago, there was a Canal del Congreso. No, I don't know if that still exists. But you would turn on the TV. I know most of you don't use normal TV anymore. You just use Netflix and all those things. But you would turn on the TV, jump into the channels, and there was channel, I think it was 9, and there was a camera on from the Cámara de Diputados and Senadores. And you would hear them discuss a topic. Can you imagine something more boring than that? Okay. And now imagine that language, that's a lawyer's language, combined with a technical engineering language, merge into one, that's a patent. Okay? So it can be a nightmare because it might be written not as we engineers speak, but it just use our vocabulary and it's trying to explain what it's done, but it's done like if you're a lawyer is trying to explain you an engineering concept. Okay? So we're going to go through what parts of the patent has, but now with AI, you can do it way quicker. You can even search what kind of topics are, what kind of information can I see in this? No? What risks are they? No? Or even ask, I need to validate this data. What do you suggest me to read? What do you suggest me to search for? No? Is there anything out there? Okay. But do you remember we do the search, then we ask a proper lawyer to go through all of them. But your search is going to be as good as the information that you feed. Okay. Again, like if we speak about the 2 slides back or 3 slides back when we're talking about the vacuum cleaner, if you ask, are there any patents on pumps related to vacuum cleaners? Might say no. But if you're using a kind of vacuum cleaner, a kind of pump that's already patented in a vacuum cleaner, and you're still using it to pump, you're in infringement of a patent. So you might develop all the product, and then you have to pay these guys some amount of money. Okay. The other one, we'll see it later. No? There's patents that have been voided or expired. So those might be a very nice thing for you, because if they are expired, they're free for you to use. Okay. And then you decide how if it's good or not. So this is something that we're going to be working on today. Okay. So before we get into your workshop part, I prepared a worksheet I should have uploaded. Let me find it here. Podcast, por día, material. This one is the one I need. So I'm going to hand you this. I'm going to upload it to you. So this is what you're going to be working in Teams. Okay. So this is a PDF. You can see that you can already write here. So it's going to make it kind of easy. So this is the first of, let's say, 4 that you're going to be delivering or sending me as a team for your weekly assignment. Okay. So it's long. Okay. It's 20 pages, but you can see most of them, you just got to write one single thing. Okay. But this is what you're going to be doing. Okay. Let me go back to, there it is. Okay. So it has this same arrangement. So the first thing that you're going to be discussing is the user. Okay. So in this, right now, we're going to be working for the deodorant. Okay. Again, I'm going to say it in Spanish, desodorante con cartuchos intercambiables. Okay. So that means you run out of it, you remove the part that has the chemical product, you throw it away, you put a brand new one. But the case you keep it. Okay, you keep on throwing it away. Okay, so you can start imagining that there's some issues on it. Would it be worth it? Not. What would be the constraints? We already spoke about some of them. They cannot leak. You can have those kind of issues. Okay, so I want you to work as a team, and you're gonna start filling some of these questions. So again, you'll see the worksheet in a moment. So we're going to define who's going to be the user, or you are going to design for your product who's going to be the user. Okay, again, who does this solve an issue for? Okay, imagine that this is your company that's hiring you to do it. Okay, maybe you as an engineer say, this is crap. No, nobody's going to buy that. Okay, maybe you think so. Okay, most of you probably do. Okay, but you're working for a company that wants to launch this. Okay, so you need to find somebody who's going to be working for it. Okay, somebody that needs it, and then you're going to validate it with data. And maybe when you get to the data part, you might not find somehow to validate it, so you can avoid this project. Okay, I can tell you there's a market. Okay, we have launched this product before. Okay, then I wanted you to put some metrics for the user. Okay, so how are you going to measure if the customer is satisfied, if the customer wants to adopt this new product, because they might not want to adopt this product. No? If it saves some time, if it saves, why would this user use this new problem solving deodorant? Okay, and the evidence right now, let's just suggest where you would get that information. Okay, so maybe I would ask 20 of my friends, would you buy this? Would you not buy this? I would, again, think about it like if you were in the business world. If you ask 20 friends, you're asking people from the same age, same area, same country, same social economical status, more or less. Okay, so you're doing it this thick. Okay, so open your mind. Where can I get more information? We're going to see this part in detail, so that's why you're going to be updating these sheets before the end of the week. Okay, but where could we get more information for who's the user? So what's the function? Okay, so in this case, it's to apply deodorant to your body. Okay, but what's the function to solve? Okay, how are you going to put this new cartridge in? How are you going to seal it? How are you going to do it? So how you load, what's the precision, if there's a speed, no? So I'm going to help you with maybe function. One of the metrics should be it does not take more than 10 seconds to load the cartridge, a brand new one. To unload the old one, load the new one. Maybe 10 seconds is way too much. Okay, but those kind of things is what you got to think about. It's like, okay, no, I got it, it's empty, I throw it out, put it in. Hey, is the function going to tell me when I'm low in the other end or not? Is it going to, by itself, it's going to pre-order a new one? You can make it as complex as you want, but again, you got to validate all this information. Be careful about it. Okay, safety. How can it harm you or the environment? So here's a very easy one that I hope that you guys put in evidence. If this product we're talking about something that you're going to be replacing with a new cartridge, what would it have to do with environment? Just think about it. Okay, manufacturing. Can we manufacture this product? Can it be easily part? How many parts you can do a first design in your head? Like we can do this part, so maybe we need like 6 parts. No? How many cycles do we need? No? Is it going to last for 50 years, 20 years, 5 years, 2 years? Okay, after 10 cartridges, you got to buy a new one. Okay, again, this could be a very marketing thing, like buy a subscription and every 10 we send you a brand new one. We're not going to deal with that part. We're dealing with the engineering part right now. Okay, questions on this first 4 points? Has anybody got any questions? Because you'll be working in teams. If I can pop it in and out with your teams. Nope.
Well, I have a question.
Yep.
I don't know if you say it, but it has to be like a bar. Like it's like there are many types of deodorant. So
No, the only thing it needs to be at the other end. You can replace, let's say, the product that is the deodorant chemical part.
see,
Okay, it can be liquid if that was your question. It can be no, because it does not specify. It only specifies that you need to be able to change the cartridge. Okay,
okay, okay.
so that's a good constraint question. Somebody else? Are we all clear on user, function, safety, manufacturing? You'll see that the worksheet helps you quite a bit too. No, all good? Okay. Cost. This one, you need to work a little bit on it. BOM, does everyone know what a BOM is? It's bill of materials. Okay. So if I have, let's say, these R2D2, I have one head, one body, one right leg, one left leg. If the legs are identical, I have two legs, one body, one head. Okay. So and in this case, it's spring. Okay. So my bill of materials to build this, it will tell me how many parts it is. I don't think we're going to do that today at all, but I do want you to kind of play what kind of cost do you think we can sell this product? Just from the top of your head. Just think about it. If you go to Walmart or wherever you buy your deodorant, how much does this product that you already have is sold for? And how much do you think, what margin do you think we could overprice it to be able to have it an external or exchangeable cartridge? Okay. Maintenance. I don't know if this is in it. Does it need any maintenance? I'm putting some things here to help you out. Like if it needs to be repaired or it needs to be cleaned. Okay. So you do understand the hint, right? So maybe let's say not repaired, because who would, but it does need to be cleaned. Or can you make sure that it does not need to be cleaned? Okay, but this needs to be in your scope. If every time you change it, we're gonna clean it, we're not gonna clean it. If it needs to change that O-ring, if it needs to be changed every whatever it is, those kind of things we need. Okay. Again, if you think of how you're going to build it, if it's going to have a screw, if it's going to have a label, if it's going to have an electric motor, if it's going to what kind of things you need, those you can start putting it in a metric. Because if you're going to use a metric for an electric motor, you need to know how long the battery is going to last. Okay, so that's the maintenance too. How many times that I need to charge it in the next amount of time. Okay. Compliance, right now it's going to be difficult, but again, I know your generation use AI for everything, so you can kind of define all the legislation for a deodorant. No, let's work for it right now. It has to work in Mexico. Okay, that's going to be one of your constraints. Okay, if you want to do it for another region, you can do it for another region, but what kind of complaints it has to have? Okay, so you'll see that probably some countries do not allow anymore that deodorants have aluminum in it. No? Some of them do. Okay, so that's going to be a compliance, a legal compliance for you. Okay, can it use aluminum? Can it does not use aluminum? And this exercise, we are not going to do the chemical part of the product. Okay, so we're just going to make sure that I'm going to rephrase that part. Okay, so another team has already developed the liquid or the bar, whatever it is. We just need to make sure that we can place it into the deodorant. Okay, so something that we need to make sure is in this case, and I'm going to spell it for you, is they cannot be aluminum in touch with the deodorant, because it might transfer aluminum, okay, and then it's not going to be legal in some countries. Correct? Do we all understand that part? Like for this example, like aluminum in a deodorant, it's banned in some countries. You should not use aluminum in the area that's in contact with the product that you're going to apply to your body. It can be in the part that you grab it, but not in the part that it's in direct contact with the thing that you're going to put into your body. All clear in that part? Anybody has any questions, or was I unclear? So you see how precise you start to be in every single part, right? Like that's why you're working in teams. Like you're gonna start discussing this kind of things. Like, okay, so it says you cannot, I don't know, deodorant in Australia cannot be red. Why not? I don't know. Okay, but it cannot be red. Okay, so if it cannot be red, what could my product that's only the case be in non-compliance with this legal thing that cannot be read? There's nothing, so don't worry about it. Just write it. We read that at the other end cannot be read in Australia, because when you get to a stage and then there's a lot of red in your product, just make sure because you already found that. Okay, just don't get rid of that kind of information. Okay, sustainability. Okay, so this is going to be a very easy one at the beginning. So it's just going to get a little bit more complex then. But does it reduce an environment impact? So you can see that that's mainly the reason why you're doing this, right? Now, what's going to be the metric? That's very interesting. Okay, if I have a full deodorant and I'm going to throw it away when it's done, and now I do not throw it away, but the packaging for the cartridge is the same amount of plastic that I throw away, there's no environment saving or reduction. Okay, so one of your metrics, I'll help you out with this one, is that the packages where the cartridge comes, it has to be 100% recyclable. It has to be 55% less plastic than the original deodorant. Okay, you got to find a way that it meets your criteria for it to be sustainable. All clear for this? Anybody has any questions? You guys have very few questions. It makes it very easy on me. Okay, so at the end, I'll show you. It's going to have to look something. Oh, you see, I do my presentations. Bloody hell. I cannot read. Okay. So I did this quick one from another job. So let's say that we're going to do the same thing for a car seat for a child. Okay. So you're going to see at the end, let me reopen that PDF. So you can see this. Okay. So you can see it's the same thing that we've been talking about, all those 4 criteria. Okay. It explains you again in those 20 pages, so don't worry, every single one that we just spoke about. And it's suggested for you to score from 1 to 5, okay? And then here, this is your team information. So slide 3, it's free for you. So it's what's the name, you can name the product or put the name with who are the team members, blah, 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 no? Okay? And then what are your concerns for users? Okay, here it says user. So you're going to put all your initial data here. Everything we spoke, it's going to be for people from this age, this kind, no? That are rich, not rich, people that do not have access to the deodorants, people that are in war, people that are in this kind of climates, the people, blah, 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 all of those, okay? What kind of evidence you need, let's say what kind of evidence you need to collect, what are going to be your metrics, how do you score it, okay? If there's any risks, okay, we just spoke about some risks about it, okay, and what could be like improvement actions, or what are the improvement actions. Okay, why is it worth it for the user in this case? Okay, and then you give a final score for this. Okay, so yeah, I say it's really worth it, it's great, 5. It's very 3. It's 1. Okay, all of this you'll see you're going to need evidence in all of them. Okay, then you're going to do the same thing for the function, for safety, for manufacturing, for costs, maintenance, every single one we saw. Okay, and then you're going to come exactly to this sheet. So if you see, it's very similar to this one. Okay, I did it here in colors and green, and you can see I'm terrible at aligning things. Okay, but you can do it in numbers. 5 being really, really good, 1 being very, very bad, or you can do it in colors. No, again, this is information for you. Okay, so who's going to be the user for a child's car chair? No, a SID. Okay, so it's a parent that installs it. He needs to be able to understand how it's installed, and it has to comply with. In this case, it's we did this program in England, so it's Her Majesty's, or in Mexico is, ¿cómo se llama el que? Profeco, I think it is, right? That kind of it's going to check that it is, or the ISOs that it needs to require. Okay, so what it needs to keep clean, guides to for indicators and installment. No, what is their safeties? No, we need to retest after the shell has been changed. Okay, and I'm going through those kind of things. This is very, very already narrow it, but this is what you need to be able to deliver by, let's say, probably the end of the day, the end of the week for sure, working as a team. Okay, all clear? So this is what I just finally explained. So you're going to be working in 3, 4 teams. You're going to be filling this matrix that we just saw. Okay, I'll leave this for you to kind of read it again, but you'll see that it's very, very similar to what you already got. So I was given no, I've been told that I can upload. I'm going to stop sharing for a sec. Okay. Because I forgot. Oh, it's actually here. Okay, guys. So let's see teams. Hopefully all of you are in a team, because sadly, whoever is not in a team might need to work by themselves right now. Okay, let's see. Let's share. No, I thought I had already saved the teams. We do have an issue because they're way more. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. If we are 20, we can do teams of 5 or 4. I think 4 is better, but I can only see 13 of you. This is my issue. You guys have more experience with. So this is all I see from you guys. I only have 13 of you to be able to work on teams. Well, let's work today without Teams. Sorry for that. I'll tell Isa to help us out. Not really sure why. So let's do one thing. Where's my email? Let me see if it really works that way. So I've been told if I send an email to this email, everybody gets the material. Where's me? I'm doing it. I'll get better at this part, guys, I promise. The first time I ever used Blackboard. Diego cursos. Okay, guys, I just because not the guys that are not enrolled in the class, or at least they won't be able to see it. I just send you an email to your email, UP email, that says class 1 worksheet. Hopefully you guys got it.
Mm.
Can you upload personas? Let's see chat. Can we upload it through the chat?
Yeah.
Let's try it. ¿No les llegó el correo?
No, no, teacher.
Y luego se tarda un poquito en llegar, profe, pero
Pero si
debería
llega.
llegar. A mí todavía no.
Sí. Ah. Si no, a ver, ¿dónde está? Didn't get the email. Fantastic. Implementos. Ay, ay, ay. Oh no, ahora me lo reboto. Vamos a volver a intentar. Chaco. Let me know if you got it. Still gave me another email.
I got it.
Yeah, you.
Okay, guys. So what we're gonna do is, while we figure out how we can work this as teams, it might be until tomorrow after I work with Isa for her to help me create the groups and adding incluso Rodrigo into the one of the groups, because I can only see 13 of you and there's 20 of you. So the good news is we're going to be making teams of 4, not 5, because if it's 20 of us, it might be easier just to have 5 teams and not 6.5 teams. So open your PDF. You'll put your name on it, save it with your name, okay? And my idea is to jump in and out with you guys for to be helping you out. But let's work for it for 15 to 20 minutes, and then we can start discussing all of us. So this is going to be almost a free sheet for you guys. What do we place on those rubrics every single one of us? So I'll just grab from the list here from students. I'll just choose one of you and ask you what were your constraints or who you think is our user. You let us know. We can discuss about it. Somebody can tell me what extra things they added, and then we can make it richer, that document, and then you already have 25% done of what you got to deliver on Friday. Well, on Thursday, actually. Okay, all good. Everybody got the email. Rodrigo, did you get it too?
Yes.
Yeah, I just wanted to make sure because I don't know how it works. So, and I do apologize. I've never used Blackboard before, so it's my very first experience. So yeah, we'll figure it out for tomorrow. Okay. So come on, guys. This is the time where I get to rest my voice for a while, and you guys work on that shit and be prepared for me to ask you to show you your screen. So come on, work on it. Okay, all good. Questions? Nothing?
So right now it's like by ourselves, not in teams.
Yeah, because I cannot put you into teams for you guys to be able to talk to each other. That was my idea, because I'm missing half of the group, so it would be unfair for half of the group. So let's just work individuals right now, and then we'll discuss it, all 20 of us, so you can update your own form, and then you'll have it ready to hand it on Thursday. Okay.
Okay, thank you.
You didn't get the email. Clase tu ID. Sebastián, ¿cuál es tu ID para mandártelo directo si no te llegó?